Alright guys, welcome back to Underground Science, and in this video we'll start talking about naming alkynes. Alright, so we've been doing examples in the previous videos of naming alkenes and alkanes. And so if we drew this, right, this is just a hydrocarbon chain, no double bonds, so this would be an alkane. But then if we drew something like this, and we add a double bond in there, now this would be an alkene. And in this video we're going to be talking about naming alkynes. So if I were to draw something like this, right, so because we see a triple bond here, you should know that, okay, we're going to be dealing with an alkyne. Okay, so this would be an example of an alkyne. And so the best way to learn naming is just dive into an example. So let's start with a simple example first. Just like in alkenes, when we were naming it, when we were numbering the carbon chain, so for example, if I were to number the longest carbon chain here, but I have to number it so that the double bond is on the least carbon number, right? So we would name this alkene like that, because naming it from the left to right, the double bond is on carbon number 2. If we were to name it right to left, the double bond would be on carbon number 3, right? So 2 wins since 2 is less than 3. So the red numbering would be the correct numbering. Same thing goes for triple bonds and for alkynes. We're trying to number it so that the triple bond is on the lowest carbon number, right, in this example. So in this example, we would number it starting from here, 1, 2, 3, as compared to 1, 2, 3. So if we look at the red numbering, 1, the triple bond is on the lowest carbon number, right, 1. But if we look at the blue numbering, the triple bond is on carbon number 2, which is higher than 1. So that means the red numbering would be the correct numbering. Alright, so now that we know the correct numbering pattern, let's go and get rid of everything else. And we can go ahead and name the molecule now. So let's number it the correct way. And then if we remember alkenes, right? Like if we were to draw something like that and asked to name this molecule, we would number it, right? We would number the longest carbon chain, and then we would name this 2-butene, right? Because the prefix but is 4 carbons, and then ene means is a double bond, and 2 is saying the double bond is on the second carbon. But instead of ene, now we're going to be making sure to put the suffix "-ine", okay? So make sure now since you're dealing with the triple bond, we're going to be using the suffix "-ine". So what carbon is the triple bond on? Carbon number 1. How many carbons long is this carbon chain? Is 3. So we know the answer, the name to this molecule, right? The name of this molecule will be 1-propyne. Ine, because why do we use the suffix "-ine"? There's a triple bond. Why is there a 1 here? Because that's indicating the fact that the triple bond is on the first carbon. And prop, the prefix prop, indicates the fact that this is a 3-carbon chain. Alright, that's it for this example. Let's move on to the next example. So this example, same thing. Number the longest carbon chain so that the triple bond has the lowest carbon number. So of course we should start from this side. So if we number it like so, this will be the correct numbering, because if we were to start from this side, right, if we were to start from this side, the triple bond would fall on carbon number 5, as compared to carbon number 1 if we started from right to left. And since 1 is less than 5, we know the correct numbering pattern will be the red numbering pattern. Alright, so let's go and number it the correct way, which we found out was the red numbering pattern. And then once we numbered it the correct way, it's pretty easy to find out the actual name of it. So how many carbons long, right, is this carbon chain? That would be 6. Okay, so it's a 6-carbon long chain. What carbon number is the triple bond on? That would be number 1. So the full name of this molecule would be 1-hexyne. Alright, the suffix "-ine" because it's a triple bond, 1 because the triple bond is on the first carbon, and the prefix is hex because we have a 6-carbon long chain. Alright, that's it for this example. Let's move on to the next one. Alright, so for this example, again, we have to number the longest carbon chain so that the triple bond is on the least carbon number. So if we started from the left side, that would be 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And then if we started from the right side, that would be 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And now if we compare the numbering patterns, for the red numbering pattern, the triple bond falls on the 4th carbon. Alright, so for the red numbering pattern, the triple bond falls on the 4th carbon, and for the blue numbering pattern, the triple bond falls on the 6th carbon. All right, because that's right here. So let's write that down. So of course, the numbering pattern we would choose is the least carbon number in which the triple bond falls on, which would be red in this case. That would be the red numbering pattern. All right, so let's choose the red numbering pattern. So that'd be 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And we know that the triple bond falls on the 4th carbon, and this is a 10 carbon long chain. So that means the name for this would be 4-decyne. All right, and why is it yne? Because it's a triple bond. Why is it dec? Because it's a 10 carbon long chain. And why is there a 4 here? Because the triple bond is on the 4th carbon. All right, that's it for this example. Let's move on to the next example. Again, for this example, let's number the longest carbon chain so that the triple bond is on the least carbon number. So if we were to do that, that would be 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Now remember, I could have gone this way, so I could have said 8 and 9. However, that would not be the longest carbon chain. All right, so this is the longest carbon chain in which the triple bond is the least carbon number, because if we started from right to left, right, that would be 1, 2, 3, 4, 5, 6. Okay, so for the red numbering, the 6th carbon would be where the triple bond is, but for the orange numbering, the 4th carbon is where the triple bond is. All right, so we're going to choose the orange numbering as to be the correct numbering. Okay, now that we know that, we just identify what substituents we have. So we have an isopropyl group on the 7th carbon. So let's note that down so we don't forget it. And remember that iso counts alphabetically when you're naming molecules. All right, and what carbon number is the triple bond on? That would be 4. So the name of this molecule would be 7-isopropyl 4-decyne. And again, why is it yne? Because it's a triple bond. Why is there a 4 here before the decyne? That indicates the fact that the triple bond is on the 4th carbon. Why is it dec? Because it's 10 carbons long. This carbon chain is 10 carbons long. Why is there a 7-isopropyl? Because the isopropyl is on the 7th carbon. All right, and that's it for this example, and let's move on to the next example. All right, so we've dealt with examples where we have a substituent and a triple bond. So this is another example in which we have a substituent and triple bond. Right, so first let's go and number the longest carbon chain so that the triple bond has the least carbon number. So if we start from the left side, that would be 1, 2, 3, 4, 5, 6, 7, 8, 9. And if we started from the right side, now this part's important, 1, 2, 3, 4, 5, 6, 7, 8, 9, right? If we notice, when we start from the right side, we have a methyl substituent on the 3rd carbon, right, for the green numbering. If we start from the left side, we have a triple bond on the 3rd carbon. So which numbering pattern would be correct? Who gets the higher priority? And the answer is the triple bond gets higher priority. Okay, when you have a substituent on the 3rd carbon numbering from one side, so in this case the right side, we have a methyl substituent on the 3rd carbon. And if you're numbering from the other side and you see that you have a triple bond also on that same carbon number, in this case that would be also 3, the triple bond gets priority. So knowing that, the red numbering pattern would be the correct numbering pattern. Knowing this, let's go and name it the correct way. So the correct numbering pattern we said was the red numbering pattern, which is from right to left, because the triple bond gets priority, not the methyl substituent. Okay, so knowing this, we can name the molecule right away because we know that the substituent's off the 7th carbon, and we know that the triple bond is on the 3rd carbon, and we know that it's a 9-carbon chain. So putting all that together, we would say 7-methyl, right, taking care of the substituent first. Then we would indicate the fact that the triple bond is on the 3rd carbon, so that would be 3-, and then how many carbons long is this carbon chain? That would be 9, right? So that's nonine. So the full name would be 7-methyl-3-nonine. All right, that's it for this video. And in the next few videos, we're also going to be practicing naming alkynes, but it's going to be a little bit more complicated, and we'll deal with structures that have alkenes and alkynes in the same molecule. And I hope to see you guys there.